This lesson is Section 1 Geometry Basics, Day 4. Some of the terminology we're going to talk about, adjacent, which I think we briefly touched on before, complementary, supplementary, linear pair, and vertical angles. So the first thing we're going to say is adjacent, and adjacent is sharing a side and a vertex, but not overlapping. So adjacent angles would be angles like this. They share a common side, but they don't overlap with each other, right? No part of the inside of this one is on this one. It's like two rooms that share a wall, right? No part of this room is going to be in this room and vice versa. The next term is complementary, and complementary is a pair of angles whose sum is 90 degrees. One way we could remember complementary is 90 is if I take the C and drop a line down, now that looks like a 90 right there. Supplementary are a pair of angles whose sum is 180. It's a little harder to get there for supplementary, but if I put a 1 in front, connect the ends of the S, and connect the ends of the U, it looks almost like it could be a 180. Another way to remember the difference is C comes before S in the alphabet, so 90 comes before 180. A linear pair is a pair of adjacent angles that form a single straight line. So it would be angles that look like this, except once connected, they made one single straight line. So this line right here is one single straight line. And then vertical angles are a pair of angles that are opposite each other when two lines intersect. So if I had two lines intersecting, the angles that form opposite each other, like here and here, or like here and here, are considered vertical angles. For our first example, we're going to look at the figure and name a pair of complementary angles. We're going to name a pair of supplementary angles and a pair of adjacent angles. So we know for complementary they have to add to 90. So if I look, 37 plus 53 adds to 90. So that means for my complementary angles, remember we name angles by 3 letters. So that's going to be angle BAC and angle RST. For a pair of supplementary angles, I know that they have to add to 180. 127 plus 53 is 180, so my supplementary angles would be angle CAD and angle RST. For a pair of adjacent angles, I need angles that share a side. So I notice here, this segment AC, or ray AC, is common to both angle BAC and CAD. So for my adjacent angles, we're going to say angle BAC and angle CAD. For my next example, we have angle A and angle B are supplementary, so I already know they equal 180. The measure of angle A is 12x minus 15 degrees, and the measure of angle B is 7x plus 5 degrees. We want to find the measure of each angle. So I'm going to add these two together and set it equal to that 180. So that's going to be 12x minus 15 plus 7x plus 5. So I'm going to start by combining my like terms. I have 12x and I have 7x, so that's 19x. Negative 15, positive 5 is negative 10, and that equals 180. So now I'm going to have 19x equals, and I'm going to add 10 to both sides, 190. And now I'll divide both sides by 19, and x is 10. That's not exactly what they asked us for. We want to find the measure of each angle. So I'm going to substitute this 10 back in. So for angle A, that's going to be 12 times 10 minus 15. So that's 120 minus 15. So the measure of angle A, notice I put the little m in front when I'm talking about the measure, is 105 degrees. For angle B, I'm going to do 7 times 10 plus 5. So that's 70 plus 5. The measure of angle B is 75 degrees. And if I do a quick check, try to plug these back in, 105 plus 75 equals 180. So it's always a good idea to check your work. So you go ahead and try this one. You can pause it, and I'm going to show the answers. All right, so x was 8, and then plugging that back in, the measure of angle A was 57 degrees. The measure of angle B was 33 degrees. So we talked before linear pairs and vertical angles, right? We said the linear pair was the pair of adjacent angles that form a single straight line. Vertical angles was the pair of angles that were opposite each other when two lines intersected. So this is just a refresher, because now we're going to actually identify a linear pair in this diagram and identify a pair of vertical angles. So a good idea for a linear pair is I would pick one single straight line, right? Not a ray. It has to have ends on both sides. So let's say I chose line AE. And let's say I actually could draw a straight line. So for line AE, any two angles that form line AE are going to be a linear pair. So let's say I drew this ray right here. So my linear pair is made up of angle AHF. So for linear pair, angle AHF, and the other angle, I could either name it angle FHE or angle 5, because this angle all by itself is angle 5. For vertical angles, I need two complete lines intersecting. So if I were to go ahead and try to draw, again, line A, E, and let's say I tried to draw with DH. Notice that angle 4 was formed by those two lines, but there was no other angle over here formed by those two lines. So angle 4 does not have a vertical angle. I need to find a line that I can draw that will have with either numbers over here or numbers over here. So let's say I drew FB. Ooh, that is a darn nice line. I'm going to take credit for that one. Angle 5 is completely formed by those two lines. Angle 1 is completely formed by those two lines. So a pair of vertical angles in this picture would be angle 1 and angle 5. Notice when we have this, I talked about these two angles here, but really I could be talking about these two bigger angles here, right? The 6 and 7 combined and the 2, 3, and 4 combined. So I could also say angle AHF and BHE. Now, there are many more options for both linear pairs and vertical angles in this diagram. We're not going to name all. Right now, it just said identify A, and we only really had to name one. So now we have a postulate and a theorem. And a postulate is just a fancy math word for a definition. Basically, it's something that we know to be true. A theorem is something that somebody was like, okay, I think this is true, and then they had to prove it. All right, it's not accepted as fact until it's been proven. So the first one is the linear pair postulate, and it says that linear pairs are supplementary. And that makes sense, right? Because if a linear pair is made of a straight line, a straight angle is 180 degrees. So if I were to split that 180 degrees into two angles, they are now supplementary. The second one is the vertical angle theorem, and it says that vertical angles are congruent. So if I had a pair of vertical angles in a picture, I could say that the ones across from each other are congruent to each other. Remember, we use the curves to show angle congruence. This had to be proven, right? Somebody was like, hey, I noticed this is true all the time, but why? And then they proved it. And I'm actually going to show you, this is nowhere near formal. We have not learned what proofs are really yet, but this is going to be a super basic version of a proof for the vertical angle theorem. So if we had a diagram and we knew 3 and 4 were a linear pair because they were formed by one straight line, oh, ignore that, and 4 and 6 are a linear pair because they are formed by one straight line, I will be able to prove that 3 and 6 are in fact congruent. So we just learned on the previous page, linear pairs are supplementary. So if I know that 3 and 4 are a linear pair, that means 3 and 4 are supplementary. And if I know 4 and 6 are a linear pair, I know 4 and 6 are supplementary. So I can say 3 and 4 are supplementary and 4 and 6 are supplementary, and that is because of the linear pair postulate. I'm just going to put my little reasons over here. I'm skipping some stuff that is normally required in a formal proof, but we're just getting to the idea here. And we also learned the definitions of supplementary, right? When angles are supplementary, their sum is 180 degrees. So I could take these statements that 3 and 4 are supplementary and 4 and 6 are supplementary and turn them into equations. I could say that the angle 3 and the angle 4 add to 180 and angle 4 and angle 6 add to 180. And that reason would be the definition of supplementary, right? That's what it means to be supplementary. And now we'll notice I have two equations, and both of them equal 180. If two things equal the same thing, that means they have to be equal to each other. So I'm going to go ahead and connect them. I'm going to get rid of those 180s, and I'm going to connect these two pieces to each other. Right? If 3 plus 4 equaled 180 and 180 equaled 4 plus 6, then 3 plus 4 equals 4 plus 6. So this is a term that we haven't learned yet. We're going to learn it in Chapter 2, but it's called transitive. All right, but for right now, as long as we understand that when these two things both equaled 180, they now equal to each other, that's okay. And now I notice on my equation, I have 3 plus 4 and I have 4 plus 6. Both sides have a 4, right? That 4 means the same thing on both sides. So I'm going to take it away. And whenever you take something away from both sides, that's called subtraction, right? We know how to subtract. If I subtract an x from both sides, that's subtraction. And now the last step is they really wanted to say congruent, right? This says angle 3 is congruent to angle 6, and this says measure of angle 3 equals measure of angle 6. Those are sort of different things. So we're going to go ahead and convert that into congruence. And that is because that is what it means to be congruent. Shapes that are congruent have the same measure. So that is the definition of congruence. You don't have to know how to do this right now. I just wanted to show you why the vertical angle theorem is true. So now we're going to put the vertical angle theorem into action and the linear pair postulate into action. So I'm going to look at these pictures and I'm going to see which angles have the same variables. So in picture A, I have a 3x minus 17 here, and I have a 5x minus 47 here. These are vertical angles, so I know they're equal to each other, which means now I can say that 5x minus 47 equals 3x plus 17. So I can subtract the 3x and get 2x. I can add the 47 to 17, and I get 64. And now I divide both sides by 2, and I get x is 32. Now I'm going to look at the y's. I had a y here, and I had a y here. So again, these angles are across from each other, formed by two intersecting lines. They're vertical angles. They're congruent. So I could set these two parts equal. 2y plus 9 is going to equal 3y minus 20. So I'm going to subtract 2y from both sides. I'm going to add 20 to both sides, and I get y is 29. When I look at b, I have 11x plus 16 here and 8x plus 12 here. So the two angles that both have x in them are adjacent, and they do form one single straight line together. So these are a linear pair. So this is going to be set up as a supplementary equation. 11x plus 16 plus 8x plus 12 equals 180. Right? Linear pairs are supplementary. So combining like terms, we get 19x plus 16 and 12 is 28 equals 180. So 19x, if I subtract 28, equals 152. So that x equals 8. And now I look at my two angles with y in them. I have one here and I have one here. Again, formed by one single straight line. So these are also a linear pair. So we're going to add them up to 180. So 3y plus 13 plus 5y minus 1 equals 180. So combine those terms. We get 8y plus 12. Subtract the 12. We get 8y is 168. And divide by 8. We get y is 21. So you can go ahead and try this one, figure out if you're looking at a vertical pair or vertical angles or linear pair. Pause it and I'm going to show the answer. Alright, so we were dealing with vertical angles in this picture, so we should have set them equal. X was 11, Y was 17. The last thing we're going to talk about also comes into play in Chapter 2. It's just left here because this is the section about angles. It doesn't really seem to fit, but it is something we need to know for when we get to Chapter 2, right? The right angle congruence theorem, all right? If I know I have two different right angles, they're automatically congruent, right? We can go through the whole process of saying a right angle is 90 degrees and two things that are both equal to 90 are equal to each other and so on, but this takes us straight there, right? If I have two angles that are right angles, they're automatically congruent to each other. And that is it for day 4 of chapter 1.